Welcome to Chapter 10. Chapter 10 is all about exponents, about these things called logarithms, and about making money. And so we are going to start with just some rational exponents. 5 squared, as you recall, is 25. 5 to the negative 2 is going to be 1 over 5 squared, which would actually be 1 over 25. And then 5 to the 0, or rather anything to the 0 power, is going to be equal to 1. So we know that the square root of 25 is equal to 5. But what about the square root, what about 25 to the 1/2 power? Well, that's also going to be equal to 5 because the exponent 1/2 is actually the same thing as the square root. Basically, it's just saying the exact same thing. It's just another way of writing it. So what we're going to do in this chapter is we're going to have a lot more fractional exponents, which are all going to be square roots, cubic roots, etc. So we have b to the 1/2, which would be the square root of b. B to the 1/3 is the same thing as the cubic root of b. And then b to the 2/3, this is a little interesting. We can either write it as the cubic root of b squared, because that 2 is on the top, or the cubic root of b quantity squared. So there's kind of two separate ways of doing it. Whichever way ends up being easier. Basically, we get this kind of general equation that b to the power of p over q is either equal to the q root of b to the p, or the quantity cubic root, or q root of b to the p power. Sorry, that's hard to say. But you kind of get the point that we can kind of do it in either order, whether we want to take the root first or etc. Anyway, 27 to the 1/3 would be the cubic root of 27. When I do the prime factorization of 27, I get 3 3s, which means a 3 is going to come out because I have a group of 3 and I'm doing the cubic root, so the answer there is 3. If I look at this example with negative 32 to the negative 3/5, the first thing I'll do is use that negative to flip the negative 32 to the 3/5 to the bottom, and I've used the negative so it's gone. Then I'm going to do the 5th root of negative 32, and I'll cube it at the end. The 5th root of negative 32, if I do a tree of 32, I get 2, 16, 2, 8, 2, 4, and then 2, 2. So I have 1, 2, 3, 4, 5 2s, which means I can take out a 2 out of the 5th root, and actually I'll take out a negative 2, right? Because it's negative 32 on the inside. Negative 2 cubed is just 8, so I get 1/8 as my final answer. There you have it. Just some practice. I think that you guys will find this chapter a great relief after Chapter 9. Chapter 9 is quite difficult. This one is a little bit more algebra, and it's just kind of a breath of fresh air. So we're going to write this in exponential form. We have the cubic root of p to the 4th q. So I'm just going to basically write my cubic root as 1/3. So I end up with p to the 4 over 3, q to the 1 over 3. I distribute the exponent because everything is multiplied. I couldn't distribute the exponent if anything was added, but I can because things are multiplied. Let's go ahead and get this in exponential form as well. The first thing I'll do is kind of distribute that 1/4 exponent. So I get p to the 4 over 4, and then q to the negative 8 over 4. 4 over 4 is going to reduce to 1, and negative 8 over 4 is going to reduce to negative 2. So I just get 1 over p, q to the negative 2, and then I can put both of those on the top and write it as p to the negative 1 q squared. Okay, so remember we're kind of converting these square roots and stuff to fractions, and then we can distribute them across multiplied terms that are all under that radical, right? Which can be really helpful. This one we're going to simplify, but we're going to simplify into radical form, so we're going to keep it as a radical. I notice that I have the 6th root both times, which means I can take the 6th root over both of these terms and just divide them on the inside. And 8 cubed divided by 4 squared in your calculator gives you 32. So the answer is the 6th root of 32. If I do the prime factorization of that, I get 5 2, so I can't really take anything out. So it's just the 6th root of 32. Now we're going to simplify in exponential form. So I have x to the 3/2 minus 2x to the 5/2 divided by x to the 1/2. So I'm going to distribute that divided by x, right? I'm going to distribute to each term inside the parentheses. I get x to the 3/2 over x to the 1/2 minus 2x to the 5/2 over x to the 1/2. Now I circled these because what we're going to do is we're going to subtract the exponents because it's the same base, right? They all have x, 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 x. And so I'm going to subtract each of the exponents. So I end up getting x to the 2 over 2 minus 2x to the 4 over 2, which is the same thing as x minus 2x squared. Pause the video if you needed to work that out kind of slowly. So we're going to solve an equation now. I have y to the negative 1/2 equals 6. To undo this exponent negative 1/2, I could just raise it to the power of negative 2 because those two exponents would multiply, and negative 1/2 times negative 2 is just 1. So y to the 1 is equal to 6 to the negative 2, which is 1 over 6 squared, which is 1 over 36. I'm going to do the same thing with this guy. but I'm just going to multiply it by 2, the exponent, which is really like squaring the whole thing, right? So I'm going to square both sides of the equation, finish solving by subtracting with 9 from both sides. I get x squared is equal to 16, and then x is equal to plus or minus 4. Good luck on your homework, and have a great day.